Everybody here in this wonderful venue. It's my pleasure to give you my warmest welcome to this workshop on behalf of the whole department. Our department is called Department of Electrical Engineering and Information Technologies, and as the name suggests, it spans a quite wide range of topics from industrial engineering to information technology. And in fact, we are running a lot of, say, undergraduate programs, but also a few master programs like the master that we are dealing with today. And in fact, I'm particularly glad to be here because this master is something that we are really pushing hard because we really think that it is very timely with respect to, say, what happens on the mass media and so on, because the topic is very hot, so to say. And it's also very much in line with the interest, the scientific interest of our department, because we have quite a strong team dealing with the topics related to artificial intelligence. So I think that this is a wonderful occasion for us to gather together people coming from different backgrounds in order to, make an advance on this important topic of artificial intelligence. And in this respect, I really wish you a very fruitful meeting, and I would like to close thanking the organizers, Professor Sansone, first of all, for inviting me to give this very brief welcome address, but also for organizing the workshop itself and for running this master program. Indeed, we are just completed the first year of the master program. I guess Professor Sansoni will give some details after, but we are very much interested in going on with this master also for the next year, which is already decided, so to say. But we are also planning to extend the duration of the master also in the coming years. And in this respect, we are trying to, and we already found, say, possible sponsorships and, say, institutions interested in converging to delivering this master. So we really believe that this initiative will not end soon, but will go on for very many years in the future. So I stop here, and again, I thank you all for coming here, and I give you my warmest welcome and warmest wish of a fruitful meeting. Thank you very much.
Thank you. Thank you very much, Fabio. So now I'll give you a few words about the program and also about the motivation of this workshop. The idea is to provide you some insight and tales related to the first edition of this master. As Fabio said, this master was funded by a project funded by the European Commission. Human-Centered Artificial Intelligence Masters is the name of the project and also the name of the master. So in this project, there are 4 universities, so there are also some colleagues here from the other university. In the next few days, it will be also a program management committee meeting related to the project itself. So as Fabio said, last week, it was the first graduation day for the first 6 students of the first cycle. After these, other 6 students will graduate next month. And after that, maybe the last day of this week, or at least at the beginning of November, the second cycle will officially start. So in this day, we will try to say something about the first year, as I said. In particular, we will start with the presentation of 2 of the students who graduated last week, and they'll talk about their work in order to give you some a real example of the work during this first year. After that, I asked for a contribution for a couple of members of our university, mainly related to the social and ethical and legal aspects related to the artificial intelligence. Since the main aim is to demonstrate that now it is not possible to work with artificial intelligence only by technological, by an algorithm point of view, but there is a real need of considering both ethical and social aspects, and also it is necessary to know what are the regulations behind the possible use of this kind of technology. So it is necessary to see the point of view of an ethical and social expert as well as an ethical expert. After that, it will be a little break, and then I also asked to the companies and also to the Excellence Center that are part of the project itself to give us some insights related to their work during this period. In particular, it will be a presentation by the CNR and also a presentation by the FIVEN Group, which is the Italian company that is partner of this project. Finally, there is a final contribution given by AWS. The AWS is not a real partner of the project, but anyway, it is, in some words, a way for closing the ring, in the sense that when the call about this project, about the application to this program started in 2020, we used the Amazon platform HCAIM, and also at that time there was also the interest of AWS in order to participate to the program. So in some way there is a way in order to closing the ring in a final way. Okay, so it's time to start. And then, as I said, in the first part of the program, there will be the presentation of two of our students. The first one is Lidia Marassi, and she will present the work performed for her graduation at the first cycle, searching for social justice in AI. The advisor of this work is Professor Stefano Marrone, and the co-advisor Francesco Vergiulo, Dr. Francesco Vergiulo from CNR. Please, Lidia.
Nowadays, okay. Probably nowadays it's not possible to think of AI without also thinking about the ethical and legal implication that AI poses on our everyday life. So basically, this thesis aims to be mostly ethical oriented. Okay, grazie. and deals with the topic of social justice theories in the field of AI. So as despite the current use of AI within society, it also seems to be a lack of theoretical frameworks in which to understand the real meaning of these solutions, also from an ethical and a legal implication. So I propose that the transformative role of AI could be seen through the lens of social justice theories, and in particular a social justice theory which is called the capability approach. So in order to understand the relationship between distributive justice in general and theories of justice in general and AI, we have to say that of course we are talking about a philosophical topic which was mainly discussed in the ethical field, and also has received different definitions depending on the theory of reference. But here we were talking about distributive justice, which is a theory which is mainly related with the name of John Rawls, who was recently added as the favorite philosopher of AI. So distributive justice theories basically are based on some political principles concerned with the fair and equitable distribution of resources within a society, so in the equal distribution of resources to society members. And in the field of machine learning, it has been emerging the so-called fair machine learning with the goal of addressing algorithm injustice and the redistribution of possibility within the field of AI. So it's mostly about solving the problem related to bias. And so it's a concrete attempt to apply theories of distributive justice to the proper design of a machine learning system. But there's also, of course, there are also different approaches. And if theories of distributive justice consider individuals and the welfare of a society in a collective sense, they can be partly insensitive to personal heterogeneities. So when we're talking about AI, probably it's not the best way to understand all the implications that AI has on social justice. And so there's also another approach, which is the capability one, that does not consider the redistribution of resources, but mostly the possibility that some people have to be or not be able to convert resources into welfare. So in this case, capabilities are meant like actual opportunities to be or not to be or to act in a certain way. For example, the opportunity of having a long life or be able to be creative and so on. And the capability approach has already been used in the legal field, for example, and also in the economic one, and focuses on promoting and expanding those capabilities as the direct access to human well-being. And so, in this case, also to social justice in a collective sense. So since AI is reshaping the definition of some of those capabilities, for example, we can consider the role of AI in the medical field, and so the role that AI has, for example, in accessing the possibility of having a healthy life, we can consider that AI itself could be considered among the condition of possession, and so the realization of the capability that AI in itself is transforming. So like another access to the same capabilities and also to potentialize the capabilities. So for example, this is mostly notable with the case of AI, generative AI, for example, as generative AI let people act like an amplifier of human capabilities, enabling people to expand their possibility, for example, in a creative sense. So this is just an example, but in general, to guide the development and the use of AI in a fair and ethical way, of course, this approach could be also declined not only from a theoretical perspective, but also from a formal, a normative, and an educational one. If we were talking about the normative attempt to understand if there can be a more ethical AI also from a normative level, this attempt has already been made by the European Commission, which is perfectly aware of social issues and implications that might arise of an unfair use of AI. So the AI Act, which was approved this year, is a de facto attempt by the European Union to regulate the use of AI and also considering the implication also from an ethical point of view. And the basis, it deals with the possibility of outline shared ethical principles in the right approach to those technologies. So this is an attempt which does not explicitly adopt the capability approach framework, of course, but there are some of its principles that can converge to the basic values that are also shared in the capability approach in itself. In fact, they both consider the fact that considering AI as a capabilities in this sense, those capabilities could be designed to protect human dignity and, in general, people's fundamental rights, which is also the approach which is shared by the AI Act in itself. But while the capability approach provides an ethical framework, or could provide an ethical framework for assessing human well-being, the AI Act is a proper attempt to translate this principle into regulations. And it's not that difficult to understand that could be a similarity between the capability and the AI Act in the legal field, as it's already been used in this field. But of course, it's not just about regulation, and this for two perspectives. The first one, that is already been anticipated, that if AI constitutes one of the conditions for the development of those human capabilities, of course, the improvement of AI in an ethical way could be necessary for social justice in this sense. But for the same reason, it could be also possible to apply the same value which are promoted by the capability approach in itself to the AI development. So as for the second point, the capability approach could be also seen like being representative of some ethical principles which can be included in the design of AI system, which is not that different from which was already been made for the fair machine learning field. And from a European level, there are also ethical principles which are already being considered in the document of in the proposal, the AI Act proposal, also because they are collected in a document which is ethical guidelines for trustworthy AI, which was used for developing those proposals. And in addition to providing a conceptual framework, we can also see that within the capability approach, there are some ethical benchmarks that could be used to improve the fairness of AI models if we consider that they may have a correspondent in the AI field. So considering both the ethical line which was advanced by the European Union and the ethical values which are proposed by the capability approach in the philosophical field, we can understand that a model that could be considered as fair can be outlined considering five values that can be improved in the design of those systems, which are fairness of treatment, transparency, accessibility, equity in access, and long-term utility. We are also trying with the CNR to try to understand if those aspects can be translated into actual measurable variables in order to properly assess the amount of justice of a certain system, but we're still working on that. And the final point is promoting AI education. So this is a point that was mainly discussed during the last months also with the approval of AI Act. But we are considering that for AI to be fair, it's also essential that people are not just simply consumers of this technology, but may express their opinion and also be aware of the possible ethical implication of those technologies. So today we can consider the real challenge of AI also in the educational, as educational purpose. So in order to consider the perspective of users, we try to understand it using a questionnaire which was submitted to a random samples of 1,288 people, and which were mainly women. And the research method was divided into two parts. The first part of the questionnaires aims to collect information about age, sexual gender, educational level, frequency of use of AI, and opinion on generative AI in general. And the second part was a proper questionnaire in which respondents were asked to rate the appropriateness of some images which were generated by delle according to three parameters. The response satisfies me, does not, and partially does. So in the case of the negative or neutral answers, people were also asked to give reason for their given answer with an open one. So even if there could be also a bias in the questionnaire in itself, because as I said, the people who were interviewed were mostly women, the 77% of it, if I remember well. But the results may be seen in a way in which we can notice that people seems to be generally more sensitive to female gender issues than other type of biases. The purpose of the questionnaire was to assess the understanding of users of biases within these images, and also the ability to recognize that may be different type of biases in general and different type of biases in the same image. So the level of sensitivity does not seems to be as pronounced as in the case of females in the reverse case when the images, for example, represents male-dominated scenarios. But the most important, in my opinion, the most interesting fact is that in case of images with multiple biases, participants seems to focus only on one of that. So the questionnaire that was used in the survey is still active because we want to collect more information about that, also to solve the problem of having such a number of females and not also male participants. But when we also want to provide a sentiment analysis of questionnaire responses, especially on regarding the one which were related to the general opinion of generative AI in general. And this could help also identify areas where more information and more probably education is needed. And this approach seems to be in line with the capability approach 1, and also can shedding light on how people can interpret and perceive issues related to generative AI in order to improve that and aim to focus on social justice from an ethical level. So in conclusion, we understand that the capability approach can be a relevant philosophical frameworks in order to understand the impact of AI on social justice and on society in general. And there also have been attempts to use that approach in not a direct way, but in a general sense in the justice field, for example, with the AI Act. And the application of those principles could be maybe also used in the evaluation for a critical evaluation of AI in general, in a way in which we can improve also the technical, legal, and theoretical part, but also the educational one in order to understand the complexity of those solutions in a more general way. There are also unexplored aspects that I will focus on in future, but I did not explore further in this thesis, which were education through AI, which I anticipated with the questionnaire, the understanding that there could also be possible not only to educate people regarding AI, but also through AI if we consider AI as a solution. The estimate justice in AI, which was the attempt to use the capability approach in order to understand if those values that are similar to the capability approach and also the AI field can be used as variables in order to estimating the amount of justice of the system. And the third one, maybe probably the most interesting one from a theoretical aspect, which is the exploration of an alternative definition of AI. Also, the AI Act has provided a new definition in order to help regulate the solutions, but it's more centered on the concept of intelligence. And probably could be interesting also from a theoretical level to considering a shifting from the intelligence part to a broader concept of intelligence, maybe also related to possibilities, and in this case to capabilities. Thank you.
Thank you. Okay, so are there any questions from the public? Yes, please, Guglielmo.
And so on and so forth. The other one is that there should be some basic allowance of basic goods for people, right? Exactly to develop their opportunities and their possibility. Have you explored this idea, and this includes freedom, education, health, care, and so on and so forth. Have you explored the idea that maybe also AI tools might be placed into this basic list of goods that enable people to develop their capabilities? Have you? I was unable really to see it into your slide. I don't know whether this is a
Yes, I rushed a bit probably, but yes, especially AI tools when they are related also to news-bound capabilities, if we're considering the 10 news-bound capabilities related to capability approach. For example, probably the most interesting is the concept of, the capability which is related to the possibility of developing a creative application of human life. Okay. And for example, this can be, of course, be improved by generative AI in general, as not only a direct access to those capabilities, but also transforming the possibility that people have in order to achieve them. And I'm still studying those topics, but I haven't found much related to capabilities as a framework for AI. There's mostly about Rhodes' theory of justice, but more from an operational level, more, for example, like, for example, in the fair machine learning system, but considering a more technical aspect than a social one, but yes, of course, I agree.
It might be a promising road to explore for research.
I hope so.
Okay?
Thank you, Lydia, once again. So one of the key points of this master is to mix together both people whose background was mainly in social and ethical part, and also people whose background were mainly in technological, was mainly technological. So the second presentation is by Flavia Napoletano, and as you can see, the technological point of view is for sure more significant, and the title is Object Detection Model for Defect Inspection in Aerospace, Predictive Maintenance and Ethical Consideration in Industry 4.0. The advisor of Flavia was Professor Flora Amato, and the co-advisor was Dr. Angelo Falvo. Please, Flavia.
Thank you very much, Professor Sansone, and good morning to everyone. My name is Flavia Napoletano, and Professor already said the title of my thesis, and I want to thanks to my advisor, because this thesis was realized thanks to Flora Amato and thanks to the company Net Group and my co-advisor Angelo Falvo. In this diagram, we can see the workflow on the study, on the content of this study. Starting from left to right, we can see an analysis of the context. So we are talking about Industry 4.0, predictive maintenance, and specifically, we are talking about the aerospace sector. Next, sequentially, we analyze the technique that we have used for implementing two different kinds of eye model, an image classification model and object detection with an emphasis on fine-tuning technique. In the end, we will analyze and address the important risk associated to technology like this and model using artificial intelligence in the industrial process. Industry 4.0 represents the progression of the last three industrial era. The first one that starts from steam engine in the 1784, the mass production in 1817, the third one, the third industrial revolution that starts from 1915, and now to the present day, we are living the fourth industrial revolution. The goal of this industry is to create a smart and connected factories and implement a physical and digital integration of the system and the assets, but the most important part is to revolution the cultural and methodological of the way we work. In the aerospace sector, the Industry 4.0 is revolutioning the advancement management of production and maintenance process, and the aerospace industry is known for its inherent complexity, requires precision and advanced control of operation. Key to this transformation is the adoption of innovative technology like artificial intelligence, industrial artificial intelligence, computer vision, enabling advanced management of production and maintenance process. The transformative outcomes are to improve the quality, efficiency, and safety of operation, thus contributing to redefine the future of the aerospace industry. In this context, so in the aerospace sector, the maintenance strategies have gradually evolved. It's currently a constantly changing process. In the paper made by Akuch in the 2022, they present us a diagram of the evolution of the predictive maintenance. And we can see to the early 2019, the maintenance strategy are reactive or corrective. So the intervention are made after breakdown with a high risk for safety and of course high costs. From start to the 1915, we have different approach. A preventive maintenance is based on regular planning, based on mileage or flight hours by the vehicles, but can be inefficient because could involve the replacement of still usable components. So Now, the predictive maintenance using real-time data and analysis from sensor thanks to computer vision made possible to identify anomalies before failures, so reducing cost and increase safety. Now we are talking specifically about the defect inspection and anomaly detection, because while predictive maintenance aims to predict future failures through the analysis of operation data, anomaly detection focuses specifically on identifying events or conditions that deviate significantly from normal operation behavior. So the defect inspection or defect detection represent a branch of application of anomaly detection aimed to evaluating and classifying potential defect. In our case, we are talking about imperfection or metal surface in components intended for the production of aerospace vehicles. Now we will analyze and explore the research methodology. In detail, the research is used to develop a defect inspection model with two integrated scale components. One is image classification task, and the second one is the object detection, of course, for defect inspection. The dataset that we use is used for both model, and the name is NEUDET because it's created by Northeastern University, and this database is an important resource for evaluating surface defects and detection technique, particularly on hot rolled steel plates. It contains 6 different types of surface defect that you can see in the table on bottom left, and the dataset contains 1,018 grayscale images divided into 300 samples for each of the 6 defect types. Every image are a size 200 for 200 pixels, and we can see in the reference paper Song et al. 2013 the collection mode of this dataset. The image classification task for defect inspection was we have used a convolutional neural network called VGG16 using the technique of transfer learning. The VGG16 is a network characterized by growing stack of 3x3 convolutional layer with max pooling to reduce the volume size. It's called VGG16 because there are 16 hidden layers inside. Fine-tuning is a technique used in machine learning to adapt a pre-trained model to a specific task, and you can see in the figure here that we have done the replacement of the outputs layer for our defect. There are 6, so we have 6 neurons in the output layer. Another technique applied was image scaling, and is a pre-processing step in machine learning that normalizes image pixel value. This is the hyperparameter tuning. Specifically, we have set the batch size at 32. The loss function is a categorical cross entropy. The optimizer chosen was Adam, is an optimization algorithm that dynamically adjusts the learning rate during the training process. And the number of steps are calculating on the training samples and on validation sample. And after a lot of experiment, we have chosen to train the model for 15 epochs. This is the evaluation. We have very good prediction on training and validation set. Of course, you can see in the table the metrics of accuracy and loss, and you can see on the left the loss curves and accuracy curves compared training loss curve and on blue line, and the validation loss curve on orange line. The valuation on the test set was carried differently because we have used the accuracy score function of scikit-learn, and the accuracy value on the test set is 1972%. We also used the confusion matrix, show us the performance of the classification algorithm. The row represents the actual label, and the column represents the label predicted by the algorithm. On the main diagonal, we have the results, so we can see that we have only one error, so indicating that our classification model is very accurate. For the object detection task, we used object detection API of TensorFlow, and also we have chosen the model belonging to TensorFlow detection model Zo. The chosen one was efficient that did 0. And for this configuration, you can see the architecture of the model in the figure. And for this configuration, it's necessary to use the protocol buffer, is a serialization mechanism for TensorFlow structured data, and also, of course, TFR records is a TensorFlow format for a binary file containing sequences of serialization protocol buffer. We also used a label map. It's a file for associated class labels to unique numeric value. During the training, we have using TensorBoard, is a visualization and monitoring tool provided by TensorFlow. We can see in the figure the learning rate on top and the loss function at the bottom, both compared at the beginning of training phases on left and at the end of the training on right. In the object detection, inference is the process in which train a deep learning model. So during the inference, the model takes an image as input and returns a bounding box surrounding the detection object, along with their class labels and a measure of confidence that indicate how confident the model is to identify the object. We can see the color legenda associated for each defect, and on right we can see the prediction of our model on test set. Now, in the Industry 4.0, with this rapid technological evolution and increasing of integration of artificial intelligence into the industrial process, is redefining the global economic and production environment. So this transformation raises fundamental ethical issues that require careful consideration. These issues are essentially to ensure that AI not only improve efficiency and productivity, but also respect ethical principle and human decision-making. The automation bias is a crucial ethical issue in Industry 4.0 because this is a bias that indicates the tendency of the human operator to overtrust automated decision, even when they may be wrong. In industrial context, automation bias often leads to prioritizing AI decision over personal judgment due to perceived inaffidability of smart technology. An important aspect of automation misuse is reflected in the inadequate monitoring or control of automated function, a phenomenon commonly referred to compliancy, defined by Sheridan and Parasuraman in 2016. And they also, Menze et al. In the 2016 report a typical example in pilots, or aerospace pilots, who rely so much on the correct functioning of the autopilot that they neglect to monitor and control it properly. So one of the possible solutions to address automation bias is the implementation of meaningful human control with automated system. This approach aims to ensure that even in the presence of advanced automated technology, humans maintain a central role in decision-making and interaction with such system. You can see some example, but in my opinion, I think that we must repeat some on that, in particular active supervision, because the operators can intervene or modify automated decisions for flexibility and accountability. Also critical evaluation, because the user who must interface with the model are trained to understand automation limitation, promoting the discernment, but also shared responsibility, because humans maintain an active role and ultimate responsibility in decision consequences. At the end, probably the personal training is essential for this kind of technology because the effective interaction with automation promoting adaptability and competitiveness in the Industry 4.0. That's all. Thank you to everyone. Thank you to our professor, my advisor Flora Amato, the teacher of this beautiful master that accompanied me in this journey. And thanks to my co-advisor Angelo Falvo and the company Net Group. Thank you.
Thank you. Thank you, Flavia. Okay, so there is room for questions, some questions. Are there any questions from the public? Maybe not. No? Ah, okay, oh, sorry.
How do you see meaningful human control in the task that you are,
Yes.
in the specific task, okay?
Yes,
Because
yes.
of course the accuracy is very high, but maybe the infrequent error may be disastrous.
Yes.
Especially in our aerospace.
Yes.
Okay.
So this is a point of start, no? This is an experimental thesis that I have done with a company. So of course the project is not ended, but in the complete task, the company and probably I need to participate in this production to create a user-friendly interface for the operator. So the operator must to give a feedback on the prediction of the model for see this defect is this, is a scratches, yes, no. And of course the responsibility was of the human. So I hope that the people who work with this kind of model understand the important role that they have in this decision-making process. Thank you.
Thank you. Thank you, Flavia. Once again. So after our students, there is now time for the voices of some of our teachers. And first of all, there is the Professor Guglielmo Tamburini from UNINA. Guglielmo gave some lectures during this first cycle. I hope that his involvement in the second cycle will enlarge, possibly. And so the talk will be about AI ethics and large-scale risks for humanity.
Okay, thank you, Carlo. Thank you, everybody. I have no slides, okay, first of all. But let me tell you a little bit why I chose this topic. Because in a certain sense, I think you have been overfed with privacy, bias, disparate impact on social groups of the AI systems. And probably I can only learn from you some of the new applications of these ideas within the domain of AI. And you know really almost about everything about this stuff. For example, also how to intervene, how to mitigate AI biases, intervening on data sets, on learning algorithms, and so on and so forth. So I'm very happy that these ethical ideas become operational through your work. And I wish you really all the best for the success of this kind of activity in our technological society. There are some other issues, however, that I would like to bring to your attention, which are ethical issues which in a certain sense cut across the different application domains for AI, which, as we know, is a very pervasive and I would say malleable technology, and so it can be adapted basically to the performance of many tasks in many different areas. Certainly, for example, you have touched upon one of these. One of these is certainly work, human work, because of course, like other technologies before, also artificial intelligence is a disruptive technology which is affecting the world of work. And here, from an ethical point of view, we can think of at least two dimensions. One is the dignity of work, of having a work, of having independence, personal independence, and pursuing one's own plans of life through work. And the other one is the dignity within work, namely that the conditions of work preserve human dignity. And sometimes we know that automation has not preserved that, has made humans cogs in a wheel and more than persons. But I will not touch on that. But there are other elements of the same kind, namely other threats and other ethical issues that arise across the applications domains that involve AI in in a deep way, I would say. And this has to do with exactly what was the title of that I gave Carlo for my talk, large-scale threats to humanity, okay? Large-scale threats for humanity can be divided in two big classes. One is those of natural origin, okay? Like the asteroids which fell upon the Earth and destroyed the dinosaurs, right? Okay, we believe, I mean, that this is the most plausible theory for the disappearance of dinosaurs. Another one, unfortunately, is very close to us, are the volcanoes which are called supervolcanoes, which can really, the eruption can be so big that they will distribute so much ashes in the atmosphere that they will cause a prolonged winter, which affects on the survival of many species. But there are also man-made large threats to humanity, and I think that there are at least two, and unfortunately they are characteristic of our of the period in which we live, in which you will live even more than me, and these are the threat of nuclear wars, and the other one is the climate crisis, okay? And I think that AI, for its pervasive aspect, is having an impact on these two big threats. Of course, it can have a positive impact. For example, for the climate crisis, I hope and I wish that some of you will work in developing AI applications which will be able to support actions mitigating the climate warming. For example, helping in the meteorological forecast or in the climate change forecast or many other positive applications, optimizing, for example, the consumption of electrical energy of other sources of CO2 or other greenhouse gases. But AI can also contribute to the enhancement of these threats. And this is a topic for ethical reflection, okay? Let me start from the climate crisis, okay? Yesterday afternoon, I read a title in the New York Times, and the title was about AI thirst for electricity, okay, which was written by a PhD student of a Dutch university. Not the article, but the article was about the work done by this student. And presently, or in a few years, AI, the surprising figure that I gathered from this article is that the projections are that in a few years from now, AI will account for 0.5 to 1% of electric energy consumption worldwide. Since air traffic, plane traveling accounts for 2%, you see that it's a sizable quantity. And this depends on many issues. I suggest you to read this article by the young man is called von Vries, I think, von Vries, it's a Dutchman. And why is this important? Because in a certain sense, electricity, maybe we can think, okay, the electricity, we can produce it from renewable sources, okay? And so we solve the problem at its roots. That's true, definitely. But the projections today is that there will many decades will be needed to achieve that. So far, today, in the world, between 50 and 60% worldwide of the electricity is produced starting from fossil fuels, okay? And this, according to many studies, a recent one this year from Exxon, on account of many different factors that will intervene, will continue to be so in spite of the efforts of producing from renewable sources. So this means that also AI is produced using fossil fuels. So what can the various parties involved in AI do? Huh? Okay, the hardware, definitely you will have to use energy more efficient systems, like of course the graphic processing units, or improving or that. And there are other things that can be done, for example, relying on data centers which are supplied with the green energy, electric energy. But more specific for AI scientists and professionals like you is the idea of developing system architectures and algorithms more efficient both for the learning and the statistical inference later on of the AI models and their applications. Okay? Well, this is something that that should be done. It's a necessary condition. It's not even clear that it will be sufficient. It will be sufficient to curb the carbon footprint of artificial intelligence. Because we have to take into account so many factors. It's very difficult to make real predictions. For example, because of Jevons paradox. The more you make a source and a technological source efficient, the more it will be used, the use will be multiplied, and then, of course, you lose all the advantages in terms of energy consumption. Of course, this recommendation, this good practice, would be especially interesting for deep neural networks models, and especially so for large language models. You know that these models are becoming bigger and bigger in terms of their parameters especially, but also the other parameters that you were talking about before. Okay, but the parameter, and there is a proportion between the number of parameters, which are now in the number of billions of this connection between neural units, and the electrical energy consumption. Okay, and unfortunately, the quest for ever more accuracy of this model is pursued by making these models fatter and fatter. Okay, and this creates also some sociological problem for research, because universities are unable to afford sometimes the competition for more accuracy on these grounds, because so much hardware and software resources are needed that are not available but at the big companies in the field. And so that's another important issue for justice, and for, for open society especially. But so can we ask individual scientists to pursue these good practices? Certainly yes, but there are many difficulties that I think in the ethics of AI should be taken into account. So for example, okay, you know that, do you know anything about the cognitive heuristics that people like Kahneman, Tversky studied and achieved Nobel Prize for that? So there are lots of cognitive shortcuts that we apply in our problem solving, in our decision making. So for example, one of the shortcuts that we usually apply and make it very difficult to act against the climate crisis, to mitigate climate warming, is the hyperbolic discounts that we apply on future benefits with respect to present costs. To change one's own habits in research, even in AI, okay, costs a lot now, but the advantages to work for a green AI we will see possibly, but maybe even not, in a very distant future. And these gains are highly discounted according to our way of proceeding. It's like when Carlo or I commit ourselves to give a talk, it will be in 1 year from now. Okay, we discount it very much, and then 1 year from now comes immediately, and we regret that we have accepted to give this talk. Okay. Another thing is that we cannot apply affective heuristics. We know abstractly from the models of climate warming that things are getting worse, but we do not experience it. So we don't have any visceral experience of that. We don't have what Antonio Damasio called the heuristics of the somatic marker. He said that for humans at least, to prune the decision tree is very important to have positive and negative affects towards different choices and options. Okay, so there are these, but there are many other biases that are, so the individual researchers or the groups of researchers have a hard time to change their attitude, even they are very aware of this issue. In fact, I think that if we ask how many people are practicing green AI in our own university, I think that we will be actually disappointed. So it's here there is the ethical mission and the ethical action must involve, and you have to involve, the professional associations. Only the professional associations of AI and other related fields can change the goals of AI and say accuracy is not the exclusive idol, is not the only goal to be pursued. We have to combine accuracy with energy efficiency. And so in this way, what happens that we have rewards in the short term because we will be able to publish good papers in good journals because this will be prized, and not only the search for I don't know, 10 to the minus 3 improvement on accuracy or things like that. So I finished with this. So I think this is has to do with probably the most important ethical issue and challenge and threat that we have to deal with in our times. But there is another one which has surfaced again with the Ukraine war and Russia involvement in that, and unfortunately also from what we are hearing since last Saturday, because Russia is a nuclear power, and Israel, even though it's not officially so, is widely believed to have nuclear weapons. So what is the role of AI into the military nuclear enterprise? Well, fortunately, all, I think, nuclear powers agree in informal, less formal statements or even formal statements that the authorization to use nuclear weapons should never be given by a machine. Okay, so there will always have to be some kind of meaningful human control on this process. Nevertheless, there is definitely an arms race, an arms race involving AI systems between the big military powers. What's happening here? Ah, ecco, bravo. Grazie, Claudio. And what was I saying? Yes, that there is this military race, but that's to do with AI in many aspects of warfare. But especially, I would like to concentrate, I have only 3-4 minutes, I would like only to concentrate on nuclear systems. It's been suggested, officially so, for example, for the National Commission, US National Commission on AI and Security, that AI can play an important role in what is called NC3, Nuclear Command, Control and Communication Systems. And especially they suggested for sensory data analysis and fusion in nuclear early warning. Okay, so to warn whether there is an attack, an ongoing attack. Okay, what is the motivation? Because you know, especially under the option of reaction under warning warning of a launch, decision makers have between 0 and 20-25 minutes to respond. So it's very tight. It's there where the rationality gets lost, right? So maybe they said AI can help buying more time for these decision makers. But we perhaps can examine critically this suggestion. Is it really so? Huh? Because we know of so many vulnerabilities and opacities. Sure, AI can respond very quickly, but we know that it's a black box. The best systems are mostly black box, pending results in explainable artificial intelligence, which is very interesting, but we are still waiting for breakthrough results there. So what happens is that the human decision makers cannot ask the system why. Why are you telling me that there is a launch? Should I trust you? So here there is a problem which has to do with the automation bias that we have heard about, okay? And also, we know that it's the probabilistic nature of AI inference which creates an additional problem, because it's true that the errors we have seen can be very, very infrequent, but risk has not to do with the probability only. Risk is probability times consequences. And here, it's a large-scale threat to humanity. The nuclear holocaust is something that probably will destroy human civilization. So let me finish this with mentioning two things. One of the things is that the EU AI Act, which we have talked about, is completely silent about this risk of AI. And why? Because there is hypocrisy in the European Union. The European Union does not deal with military issues. The military is outside, perhaps, for, well, no, let's forget about that because I'm done already. I'm over. Thank you for 1 minute more. But really, it's incredibly outside the scope of the European Union. So the AI Act is completely silent about this. But the second thing is, 40 years ago, I mentioned this in my lecture to you, Colonel Petrov was able to detect a false positive of a nuclear attack. And he was able to resist the automation bias. And we are very grateful to his memory. Because we are here because he did that, very probably. But my question with which I finish, the system, the ecosystem that Petrov contradicted, and rightly so, was very, very primitive with respect to the AI systems of today. Will be able to maintain a meaningful human control on systems of today, which may lead us to make mistakes which can threaten human civilization? I really hope so, and I think that your work can help to achieve this goal.
Thank you. Thank you, Guglielmo. Thank you for your talk. Any questions or comments? Maybe Stefano?
I mean, as usual, your talks are very, very interesting. But my question now is, you are posing a very important point, a very important question, a very important problem. What are, in your opinion, a possible way to, I'm not saying deal with that, but at least to prepare for that?
Okay, I'm not sure whether you want to me to comment about the climate crisis and AI or the nuclear threat and AI.
Well, I'm considering the threat of AI in general, all the consequences. I mean, the point is, all the things you are talking about are to some extent related to misuses of AI, no? Because of improper uses or misuses at all.
So you are saying that AI is being misused by the big companies because the energy consumption, for example, is very, very high all over the place. So that's okay.
Strongly depends.
I get your message.
My point is, what do you think is a good way to support the society in dealing with these concerns?
Okay. Since my talk was about ethics and not about legal means, of course, okay. So my idea, one of the ideas that I mentioned, and thank you for letting me emphasize it again, is that, for example, the IEEE or other professional AI associations must be get seriously involved in changing the goals of research, for example, as far as the mitigation of the climate crisis and its consequences are concerned. That's one thing that you can do without imposing a legislation. So you can change the attitude of researchers, of scientists working in this, but they cannot be expected to do it on their own, by themselves. They have to have their associations with changing things. So that's one thing. Okay, not, of course it's probably insufficient, but I think it's necessary. And there are many other things that can be done short of a regulation, because a regulation, of course, I agree also that there is a problem that one may face a problem of over-regulation. And so ethics is very important, as a very important space in between freedom of acting and legal regulation. There is an important, as far as nuclear threat is concerned, I think that the usual road, which unfortunately over the last 10 years has been abandoned, to start with by Trump, and of course also Putin followed suit, is international negotiations, treaties, understanding, dialogue, good practices, and there is so much experience in that and you can apply this also to the military uses of AI, starting from the autonomous weapon systems and ending up with these suggestions about using AI into such a high-risk domain like the nuclear weapons.
Thank you.
Thank you once again. So the several times AI Act was mentioned, so now it's time for Professor Massimiliano Delfino from our university, to give his point of view about law and AI. The title of his talk is The Odd Couple of Law and AI, and Massimiliano also was a lecturer at the first cycle of our master. I hope that his collaboration will continue also for the second edition. Please, Massimiliano, the floor is yours.
Thank you, Carlo. First of all, I would like to explain the title of my presentation, The Odd Couple of Law and AI. So there is a question, why is this an odd couple, in my opinion? I think for many reasons, some of which are general, while some others are typical of the subject matter I teach, which is labor law. Starting from the general reasons, I have to highlight a peculiar, a crucial aspect. As we know, AI comprises two main areas of interest: the technical area, in a broad sense, engineering, robotics, computer science, data science, and so on, and the ethical area, including the proper ethics. We have there was a presentation about the proper ethics, and the legal aspects of AI, which are very different, quite different in my opinion. This is very clear in the master's program, where there are some lectures on ethics and some others on the legal aspects of AI. This is less clear in some sources regulating AI, such as the AI Act, as Carlo said, where those notions are sometimes confused. However, if you refer to the latest version of AI Act amended by the Parliament this year, the role of law and fundamental rights has been increased in the last months. I'm referring to a provision, Article 1, according to which the purpose of this regulation, AI Act, is to promote the uptake of human-centric and trustworthy artificial intelligence and to ensure a high level of protection of health, safety, fundamental rights, democracy, and the rule of law, and the environment in the Union. Another example is very clear. I'm referring to Article 3, where there is the definition of a serious incident. A serious incident means any incident or malfunctioning of an AI system that directly or indirectly might have led or might lead to the death of a person or serious damage of a person's health, but also, and this is very important, a breach of fundamental rights protected under Union law. As you can see, the death of a person is as severe as the breach of fundamental rights, and this is quite innovative in the new version of AI Act. The couple AI law is odd also for other reasons. First, the AI Act is characterized by a peculiar risk approach, as we know. The AI Act categorizes potential risks into the four main categories: unacceptable, high risk, limited risk, minimal risk. Moreover, and this is very new in the regulation of EU Union law. Moreover, according to another provision, AI systems falling under one or more of the critical areas and use cases referred to in Annex 3. Annex 3 is the annex where you can see the high-risk systems, shall be considered high risk if they pose a significant risk of harm to the health, safety, or again, fundamental rights of natural persons. There is another reason for being odd, the couple AI law. There is a magmatic area which refers to the entitlement of responsibilities. The amendments to the AI regulation clearly show that the provisions of the regulation and the fundamental rights apply to individuals, to human beings, not to robots or AI systems, which is peculiar, which is essential from a legal perspective. Suppose this version of AI Act is passed, in that case, these provisions, such as Article 21, Article 23 of the Charter of Fundamental Rights, will enter into force into domestic jurisdictions, and human beings must respect those provisions, since robots and algorithms cannot be responsible for violating fundamental rights. The problem is to understand who the responsible are. The AI Act uses different words, different terms, operators, users, deployers, providers, and so on, in different contexts. A good example is Article 4, new Article 4, according to which all operators falling under this regulation shall do their best to develop and use AI systems of foundation models in accordance with the general principle of EU law. And who are the operators? Who the operator are, sorry. According to AI Act, the operators are the provider, the deployer, the authorized representatives, the importer, and the distributor of artificial intelligence. In other cases, reference is made only to the user, or in the most recent version of AI Act, to the deployer. Who is the deployer? The deployer is any natural or legal person, public authority, agency, or other body using an AI system under its authority, except where the AI system is used as in the course of a personal, non-professional activity. This is also true for the scope of application of the AI Act. The scope of application is the deployers, not the users anymore, that have their place of establishment or who are located within union. So again, the deployers. In other cases, the provisions refer to the importers and distributors of AI systems, as well as authorized representatives of providers of AI systems, and so on. In the latest version of the Act, the term user has almost been repealed. In a few cases, it is referred to the end user, which is different from the proper user. One of the examples is the definition of transparency, which means that AI systems shall be developed and used in a way that allows appropriate traceability and explainability, while making humans aware that they communicate or interact with an AI system, as well as duly informing users, in this sense, of the capabilities and limitations of that AI system. In other examples, the provisions are dedicated to the providers and users. I'm referring to Article 13. High-risk AI systems shall be designed and developed in such a way to ensure that their operation is sufficiently transparent to enable providers and users to reasonably understand the system's functioning. The problem of the terminology of terms is crucial from the legal perspective. One of the most important things is understanding the scope of application of the provisions, which has recently changed, but this is very important. Also, from the technical point of view, you have to know who are what provisions, what is the scope of application of the different provisions of AI Act. The couple of law and AI is odd from another point of view. AI is a widespread phenomenon that a single act cannot regulate. The legislative proposals under attention must be at least two. There is not only AI Act, but there is also the regulation, the proposal for a regulation on the market for digital services, which are different, even though the legal basis are quite similar, and the legal basis is the market regulation, the regulation of the market. Moreover, for my subject matter, for labor law, AI is not confined to the two regulations. For instance, you have to consider, I have to consider as a labor lawyer, another source of the law, the proposal for a directive on platform work of 2021, and some collective agreements on digitalization that have been signed recently. These documents are connected with the AI since, for instance, the proposal for a directive has some provisions concerning the so-called algorithmic management. I mean the transparency and the use of automated monitoring decision-making systems, human monitoring of automated systems, and so on. The reference is also to another European Social Partners Agreement, the agreement of 2020, and to the latest agreement signed last year by the EU Committee for Social Dialogue in Central Government Administration, which is, again, on digitalization, of public administration in this case. Finally, I'm almost concluding, AI and labor law are also connected in another field that was mentioned in one of the master's dissertations, I think Flavia Napoletano's one. I'm referring to the topic of Industry 4.0, and above all, Industry 5.0. As we know, European industry is a crucial driver in the economic transitions that we are currently undergoing. The industry must lead the digital and green transitions to remain the engine of prosperity, according to the European Union. This approach provides a vision of an industry that aims beyond efficiency and productivity as the sole goal and reinforce the role of the contribution of industry to society. It places the workers' well-being, as Flavia told us, at the center, at the very core of the production process. It uses new technologies to provide prosperity beyond jobs and growth while respecting the production limits of the planet. It complements the existing Industry 4.0 approach by specifically putting research and innovation at the service of the transition to a sustainable, human-centric, and resilient European industry. And it is well connected, all this is well connected to the master's program, the master's approach. As you can see, the odd couple law and DI is complicated with many interests and problems at stake. Moreover, from a legal point of view, I'm talking about the legal point of view, AI is a widespread topic interconnected with many other topics, such as those indicated above, but also some other ones, such as training or the protection of privacy, which means the GDPR, the regulation on privacy. I'm concluding. It's time to conclude by saying that AI and law are an odd couple destined to be long-lasting, in my opinion. They are a young couple that must behave like those old couples living together because they have to do so. For reasons other than feelings, it's up to you, lawyers, engineers, computer scientists, philosophers, and so on, to make AI and law understand that their couple is based not only on mutual convenience. This is not enough. It's not enough, the mutual convenience. We need more. But this is not an easy task to convince the couple that its roots are not only mutual convenience. But however, this master's program is a good playground for this. I think it is a very good playground for this, since it is based on one of the most important things for AI, in my opinion, but not only in my opinion, which is the interdisciplinary approach. The interdisciplinary and multidisciplinary approach is crucial for understanding AI as a whole, from the different perspectives. Thank you very much for your attention. Thank you.
Thank you, Massimiliano. So, are there any questions? I just have a comment. Do you think that there will be significant modification at the actual structure of the AI Act, since all the different countries of the European Union have to make maybe some have to discuss internally about the actual formulation of the AI Act. Do you think that at the end the final version of the Act will be quite different from this one, or maybe there will be just slightly modification?
I think the final version of the AI Act will be similar to the version passed by the Parliament in June this year. And so I think you have to combine the previous text and the latest version of the AI Act. And so I think there will be any more amendments to AI Act. And I think AI Act will have chance to be passed at the beginning of 2024, of next year. So I think we are almost at the end of the legislative procedure, to pass the AI Act.
Okay, thank you once again. So now there is time for the break. We have a small break, more or less 15 minutes. And after that, we will continue with our industrial partners. I also forgot to mention that at the end, it will be also a welcome cocktail for all of us. Okay, so see you now once again in more or less 15 minutes. Thanks.
The coffee break is just at the end of the corridor, okay? On the left. We are shortly going to start, so if you can take your seat. Okay, so let's start again with the second session. And as Professor Sansone told us in the beginning, the second session is on the role and on the contribution of the excellence centers, so like CNR, CEDAR, and the other research centers that helped us delivering this master, and on the contribution of SMEs, so the small and medium enterprises that also are a very important part of this master. So the first talk will be done by Marco Pota from the CNR, and the title is The Excellence Research Center's Point of View on AI. Please, the stage is yours. Let's see if they are helping us from the... Okay, great.
Okay. I don't see it here, but... However, good afternoon. I'm Marco Pota, and I'm a researcher of CNR, the National Research Council, which is the biggest research institution in Italy. And in particular, I work for Institute for High Performance Computing and Networking, ICAR, which together with the IIT is one of the partners of the Human-Centered AI Masters project. So I will show you which are possible different AI requirements which can be faced by the research. And in particular, I will show you some of our experiences, in particular regarding healthcare decision support systems, geohazard warning systems, and the field of public administration, and also the field of industry with anomaly detection. First of all, why artificial intelligence can require different approaches. First, different tasks could be needed, such as regression, for example, to predict future financial values, or classification, for example, to support diagnosis in healthcare. On the other hand, we can have different data available. We can have supervised data, for example, if we have data about both patients and controls, or we can have unsupervised data if we have only, for example, in industrial application, often we have only normal working conditions of the machinery under study. But more importantly, we can have different requirements depending on the context and depending on the field of application. Most of the applications require to have good performances, but some of the applications also require social aspect to take into account the social aspects, legal aspects, and in general ethics, and what is called trustworthiness. For example, in fields like healthcare or warning alarm systems. In particular, the European Commission, you know that set up a high-level expert group on AI, which wrote the ethics guidelines for trustworthy AI, which is made of different aspects. Some of them sometimes include elements which are reflected in existing laws. All of them are defined to be of equal importance, but there could be some tension between some of them. But what about the importance of trustworthiness in real applications? In particular, also in the ethics guidelines, there is it is specified that these requirements depend on the application, because special attention should be given to those affecting individuals, such as healthcare or warning systems or public administration, while for other fields of application they could have lesser importance. It is also specified in the AI Act that applications are divided into unacceptable risk or high risk or limited risk. So, which are our experiences depending on the domain requirements? First of all, there are some requirements that are always due, such as the need of a human oversight and the need of using AI for societal and environmental well-being. But these are often accomplished. In particular, in healthcare, we also had to avoid unfair biases. I have to say that very often data are biased, especially in the healthcare domain, because they are taken from a limited sample of the entire human population. So they are, I can say that they are always biased, but we did not give to this aspect very much focus, because it is unavoidable, and it is not due to unfair willing of the clinicians and of the computer science researcher. So, which are the problems that really we faced? First, the privacy problem, because especially in healthcare and in public administration, the privacy of the data and the data governance are of special importance. And we faced this problem by either pseudonymizing or anonymizing the data, depending on the application. On the other hand, there are these 3 points. The first point is needed by all the application fields, which is that the model, the AI model, should be robust, should be accurate, and it should be, together with the results, it should give an uncertainty of the result. On the other hand, some application fields require that the model should be explainable, which is one of the points of the transparency. And these 2 requirements often go in opposite directions, because a simple model is more interpretable and could be less accurate, while a more complicated model could be more accurate but less interpretable. So we have to find a trade-off between these 2 aspects. And this problem was addressed by developing a method, an artificial intelligence method based on both fuzzy logic and statistics, which ensures that the model is robust, is interpretable, and gives the uncertainty together with the result. And moreover, it allows the user to choose the personal trade-off between accuracy and explainability. So I can show you some of the applications. The first is a decision support system in healthcare. In particular, we had to predict which of the patients treated with radiotherapy will undergo toxicity due to this treatment. What we made was to use computed tomography images, and in this case we had to anonymize the data. Then domain experts extracted the features from the images, and also we used the dosimetric features, and we extracted the fuzzy real base, which is the model to predict the toxicity. And this is an example of a simple model that could predict this problem. You can see that if we read this model, this can be understood by all of us. There are simple rules written in natural language. If the volume receiving more than 10 gray of radiation is low, then the risk is 3%. If this volume is high, then the risk goes to 59%. And the graphic below explains what are low and high. So we can see that this is a very, very interpretable model. Another similar application was due to support the diagnosis of multiple sclerosis. In this case, we used magnetic resonance images. Also, in this case, we had to do data anonymization for privacy issues. And domain experts extracted interesting features from the images, and we extracted the fuzzy real base. And we can see this other example of a model which is very interpretable, even if it is made here of 2 variables. it can be read like if abnormal white matter is low and gray matter is low, then the probability of multiple sclerosis is 93%. If AYM is low and gray matter is high, then we have 4% of probability of multiple sclerosis. And if AWM is high, then it is sure that it is multiple sclerosis. And all of us can understand this model, but most important, the domain experts which have to oversight this model, have to use this model to have a support for the diagnosis, they have to understand why the model tells some responses. Another example as well uses a fat serial base. In this case, we had to use rainfall and soil water content data and landslides data about a certain geographic region to predict the rainfall-induced landslides. In this case, we didn't have privacy issues, so we didn't do any anonymization, but we also extracted a fat serial base to obtain an interpretable model. We can see that in this case we have a variable regarding the soil water content divided into two sets, low or high, and the rainfall, the cumulative of the rainfall is divided into three, low, medium, and high. And depending on the combination of these two variables, we have a probability of landslides going from 0% to 46%. So also in this case, we extracted an interpretable model. Another application, this was in public administration, and in particular we collaborated with the Ministry of Economy and Finance, and they had the problem of associating new employees with vacant job positions. So we developed an artificial intelligence system able to describe, to characterize officers and jobs, and to measure the satisfaction of each association between each officer and each job, and then a mathematical method to optimize the assignments by maximizing the total satisfaction of both officers and managers of the human resources. In this case, we had the problem of data privacy, but in this case we couldn't do anonymization because we had to keep trace of the association between the name and the data of the officers. So we used the pseudonymization. So the officer's name were associated with a randomly generated string, and this association was owned only by the math directors, and the artificial intelligence system gave the results in terms of the pseudonyms, and then the directors decoded the results by knowing the association with the real names of the officers. Finally, in industry, we had very less requirements about ethics aspects. And so In this case, we had to do anomaly detection of a machinery which was a vacuum furnace for production of pieces in aviation sector. And in this case, the problem was that, like often in industry, we had available only unsupervised data. This means that we had only data about the normal working condition of the machinery, and so we had to use an unsupervised method. We applied a neural network-based method, in particular with architecture, with an autoencoder architecture, to learn normal behavior of the machinery and to detect when the behavior is significantly different from the normal behavior. In particular, we tested different models with different number of parameters and architectures, and finally we chose the one which was among the best ones, but with few parameters in the direction of green AI and of portable AI also on the edge. And these are the results where we can see that the model gives very few false alarms, but when we injected synthetic anomalies on the time series, the model could recognize well all the types of anomalies. So, to conclude, the type of artificial intelligence model and the way to manage ethics-related aspects must be calibrated depending on the application. And in our experience, there is no general solution, but the choice of the best approach depends on the application, on the requirements of the end user, and can be customized also on the application domain. If you want more details on these researches, you can refer to these papers. And that's all. Thanks for your attention.
Thank you for your presentation. Any question from the audience? Yes, please. There are two, actually. Okay, let's start, but we can also ask for the microphone. There are two questions if you raise your hand.
Thank you. Okay, my question was about if it's right to use the artificial intelligence about the employing in public administration, because it means to use a classifier method to divide people on assignment on a work. So basing on the particular data set used in this method could be a discrimination on people, and my question is right to use this method?
No, actually this was not a classification method. This was an association method. Actually, we also took into account not only hard skills, which are usually written on sites of employment sites, but we also used the soft skills of each officer. We used also preferences of the officer about job positions. So we took into account different aspects also related to the human well-being, and on the other hand of the the employers, and we made metrics considering all these aspects at the same time. So these measures measured the satisfaction of each assignment, and then we used a method to assign some tens or hundreds of people to hundreds of vacant positions, which could be difficult to do by humans. So this is just a separate system. Clearly, the directors used these results, but they used these at 90%, not completely. They decided also by their own.
Okay, thank you for your presentation. I have some curiosity about the task on multiple sclerosis detection. I would like to know if it's possible to have some details about the data set in terms of the characteristic of the population, if it's a public or private data set. And I would like to ask if you did some tests regarding the biases. I mean, if there are different populations in the data set, the rule that you present show or not some biases.
Yes, so actually we had, actually in healthcare, it is very difficult to have data to use, first of all. So for this work we had some data and we used that data. Often, like I told before, data in healthcare are biased because they are taken from a limited sample coming from the same medical structure which gathered this data. But in this case, there was also another bias, which was how the images were taken. Because if you take images by means of another machinery, settled with some parameters slightly different, the model does not work because so it is a general problem, the problem of the bias in medicine, and this is one of the cases. We had to write that this model work only if
Okay, thank you. Other questions? Okay, thanks again the speaker.
Thank you.
And the next speech is delivered by Alessandro Barducci from Fiven, and the title is SMEs and AI, How to Build the Electric Sheep. Very interesting title, so let's see what it's about.
Okay. So, oh wow, I guess you can hear me. We can also see the slides. Well, we are Fiven, and a relatively young company that has now good growth in the last years, and I guess we can go back. Yes, forward. Okay. We have some interesting principle, I guess, and we make our share of research and development in mainly or almost all in artificial intelligence. And we have some nice product using these tools, especially a CV analyzer, a chatbot, a sentiment analysis, possibly the best in Italy. Don't tell it loud. But let's say, okay, we are a company. So very different from a university, a research center. we have to make money, okay? And so what about AI and what about ethics, no? So first of all, this one, I guess, I really hope you know these laws, and this guy, if you don't know it, you must. And robotics law, of course, I will not remember them. Everyone knows them or should. But what's this all about? Well, we are still not able to build androids who dream of electric sheep. I mean, we are not able to to have a general AI. We still don't have singularity, whatever. But maybe we can at least build the electric sheep. I mean, some array of software and devices that have decent AI skills. And it's a start. That's our digital gray of electric ships, chatbot, mail dispatching, and whatever. And so what's relevant? What's the difference between, for example, a software, AI research? You develop a software also in the university, etc. Well, one of the biggest differences is that you have to live and to work in the real world. That means using real world data, answering to real world customers' needs, and also giving a complete product with a good interface, a nice user experience, a reliable system that can communicate with user DBs and software. Our customer can have DB with his HR data, and we have to communicate with them with their DB, not with a DB that we like and we use as an example. And also you have to do a software that really works, and works, it's quite robust. It's not acceptable that you have a software that once a day or once a week crashes, no? It's a big difference. And another big difference is using real data. And all of this keeping low cost, delivery time, and we have a global competition. We have a competition that ranges from brilliant, aggressive startups to digital behemoths who spend the equivalent of our yearly R&D budget in a couple of days. So it's difficult, it's really difficult. And here we have some example taken from a real chatbot example or mail dispatcher. In an airport chatbot, arriving late, could you wait for me? Let's try to teach, for example, a generative AI system that usually and normally airplanes do not wait for late passengers. No? In fact, we don't use generative AI for this task. And in another case, we were contacted from the customer of another airport, departing from another airport 200 kilometers away. But since in this airport they have not answered to her, she was asking to us, okay? And we receive, for example, in the mail dispatcher, we have a lot of languages, English, French, German, Russian, Greek, whatever. We had some problem lately for a mail in Ilocano. We had to add this language to our library because it's, I'm sure you knew, I didn't know, the third language of Philippines. And you have these kind of things in the real world. You have strange language, strange for us, of course, for them it's our Italian that's strange. But anyway, strange language or a strange answer, strange requests, and you don't have a clean language. We have typos. This code is not a typo, that's not by me, let's say, no? The equivalent of the original. And so this is very interesting also to consider when you study, because you of course you learn algorithms, that's great. You have to learn the general cases in the university. But when you do the transition, you have to do something that works in real world with real data, and that is easy to use, that is nice to use possibly. and that is at the same time robust, cheap, and delivery in 2 days, okay? So practically you have to be Superman. But anyway, and the important, possibly the important question here is, what about ethics? Why it is important? Why we decide to participate to this master? Okay, let's start from the real world, because we can have also some contradiction. When you build a product, it should usually do what the customer wants. This is general, no? Any kind of device you buy, you want that it does what you want. For example, you build a chair, a very nice, comfortable, elegant, robust, and cheap chair. That's okay, no? But the customer asks you to build a little heavier chair. Okay, you build it, and then she uses it to smash someone's head. Ouch. A responsibility. Well, but it's not my problem how a customer uses my product, isn't it? Well, it depends. When you produce, for example, automatic rifles, some inquiry on the possible use our customer will do of our product is legitimate, if probably necessary. Think about the debate on weapon regulation on either side of the Atlantic Ocean, no? And the different outcomes of this debate. You could say, oh, the old things, you know, the old, we have the same old usual question and the same old user answer. But AI reaches a widest diffusion and poses deeper question, even than automatic rifles. And so as a company, we have to make ourselves this question, or possibly because we like to sleep in the night and to watch to ourselves in the mirror, I don't know. But, well, the first, maybe trivial, is about accuracy. It has been poked by other speakers. For example, we have a CV screener that extracts very well information from thousands of CVs and tries to rank them according to a given job position. So one issue is accuracy. In a lot of CV, I think you know, in normal life, usually are ignored because human HR staff is unable to read them all. If we manage to extract info decently well, your CV will not get discarded anymore just because HR has no time to read it. That's great. I think it's important. No, we are giving more accuracy, we are giving more rights to everyone, to possibility of the opportunity of having a good job. But we still do mistakes. Every software does some mistakes sometimes. And we are trying, among other things, to concentrate these mistakes in ill-written CVs that would be discarded anyway by HR. But what is an ill-written CV? Okay, we ask our customer, but the truth is that someone has to decide, and this is a bit the core of what I'm talking about you today. Please remember, when you are talking about ethics, about accuracy, about justice, that someone has to decide what is justice, what is accuracy, what is everything. It's not a technical decision, it's not an automatic decision. There is no a generally accepted justice formula. No? You want to have an example, take 10 friends and ask them about the war that we have unfortunately in Ukraine or in Israel and Palestine, and you have probably 10 different opinions, okay? So let's go back to the AI ethics. The other most obvious problem, besides accuracy, is biases. So what is a job application or a loan request? We have an AI discriminating against women or against some ethnic minority or majority. Well, this problem is so popular that, as you have heard, we have an European regulation about it with strong fines and whatever. So we have to guarantee to the European Union, but before to our customers, to our potential customers, that our software is really bias-free. But how do you prove this? This is an interesting challenge as part of the thesis that we propose for the master, to measure the accuracy and the bias-free of the performance, and generally speaking, of an AI software. And it's quite difficult because you know that neural networks it's quite difficult to make their motivation understandable from a human being. You know that it's theoretically possible, but at a very high computational cost. No? Please don't be so naive that think that if your DB does not contain any gender information, we are safe, because AI can learn, of course. Let's put it in general, possibly a bit more philosophical. AI learns from real world, and real world is often unfair. So if you don't say something, AI will bring real world injustices and discrimination in our software. And the better the AI, the best he will able to learn and subtly introduces biases, because real world is biased. And that's the point. You have to decide if AI may just replicate real world, or whether we can or should introduce some correction because we want a better world. That's great. But please note that someone should take a decision, and that decision is political, not technical, not objective. No? We decide, for example, in recruiting, we already know that gender discrimination and also race or sexual orientation discrimination is strictly forbidden. I totally agree, that's great. But if the AI tells you, hey, I've noticed this guy is a single father of two and he has been without a job for over a year. I guess he's in dire need of money. If you offer him 50% of the normal wage, he will surely accept. There is no regulation against offering a lower wage to people with an urgent need of job. Okay? So we decide which kind of discrimination we don't want. Okay? This is interesting also for military and whatever, no? And so we can ask finally. I try to be quite quick because it's just to give you possible ideas that you can deepen with us by yourself, and also because we are a bit long in time, no? So what is unethical AI software? Okay, it's an unbiased software. Yes, but it's not enough. For example, the military software, okay, we can discriminate between friend and foe, but what if our military software is used by a genocide dictatorship? By the way, European Union regulation excludes military. No? Military are not bound and can operate with no rules. Control software in a chemical plant. Parameters are set up to maximize productivity. Deep environmental damage is granted. Major environmental disaster likely. Workers' health is a major risk. Should we sell such a software without any limitation? And of course the problem is that we cannot put some parameters hard-coded to guarantee that is a fair and environmental friendly software. I think that the only answer is that the software can be able to refuse by itself with the same problems that you will face and other colleagues of you have faced in the careers of engineers in the last decades or centuries. To accept or refuse a work in a nuclear plant, depending on your ideological conviction and principles, with militaries or whatever. An advanced ethical AI software is a software able to decide whether to work as intended or not, notwithstanding customer will. This is not the case today. We are still don't have so intelligent software. And possible we will be asked to not produce too much intelligent software because they don't want, the customers, that the software doesn't work as intended. We want software able to kill, but not able to ask why the killing is for example. And so we can have these humoristical comic strikes or march, and of course the problem of the self-limitation, and if it's really useful to humanity, to industry, I don't know. if we have too much regulation or if we have still too much very intelligent software, because you very love the principles, but when you do coffee and you try to make a cup of coffee and the coffee machine starts to ask you, okay, how much electricity are you using for this coffee? And which kind of coffee have you bought, etc. No, but then I want a coffee now. And that's another problem. No? I don't know if you know Galactic Guide of Hitchhikers, when there is the elevators, they start be very talkative. And just please remember, going back to Asimov, that the final solution that robots find at the end of the cycle is to self-deactivate themselves, not to damage humans. And well, in Finland, we are still building electric ship for the moment, but we are already thinking together about dreaming androids, and that's why we are here.
Let's thank the speaker. Any question from the audience? Okay, I have a curiosity actually. You also mentioned the AI Act and in general all the legislation that we are building around the use of artificial intelligence. What is your feeling and perspective from an SME point of view? I mean, are they doing in the right direction? Are they forcing the SMEs into a cage, or what is missing?
Well, I'm not very strong on this. I think that some correction could be useful. Generally speaking, it's a good idea to regulate, my opinion. So we do need some regulation. Nevertheless, some excess of regulation can be of very scarce utility for the public and damaging European research in favor of United States, China, whatever, no? I think it's a question of equilibrium, no? And it's not a question of great dramas, we will all get ruined from this, but to do some correction.
Okay, thank you again. Okay, now we have the last speech for today. This is from Adolfo Pica from AWS, and the title is Building Generative AI Responsibly. Please, the floor is yours.
So, thank you. I am Adolfo. I am the lead solution architect for the Telco IBU in Italy, and I'm also an expert of artificial intelligence and generative AI as well. That is the topic of those days. So, the reach of the IML is growing. This is some statistics that we collected. We know that the global spend will be huge, and the 57% of the executive says that the artificial intelligence will change their way to operate. We know that, and we think at AWS, that we should democratize the artificial intelligence. What means this? It means that everyone should be able to access the artificial intelligence. And in our view, we want to provide the artificial intelligence as a service. We identified the three main topologies of type, really, of companies. The large ones, very specialized, that will build foundational models that are very large and very complex to be built. There is another type of companies that will fine-tune those models and make them available to the community. And there will be another type of company, typically small developer, small and medium business, that cannot spend money to develop models, so they will access those models directly. And this is very important for the ethic, because when a company made available, or a community make available the artificial intelligence for other companies and for other communities, it must be equal and ethic. this presentation is focused on generative AI because in the last months there was an explosion of generative AI with chatbot and the new technologies. So the limit is the human, by the way. It's not the technology. You can create content, improve the productivity, industrial use cases. We have seen some very interesting use cases in healthcare in the previous presentation, but also the connectivity, predictive maintenance. It's plenty of opportunity about the generative AI. But just what is the generative AI? Generative AI is powered by large models. We reach, I think the largest one that I have seen is 64 billion of parameters. So super huge models to create new content, idea, conversation, story, summarization, classification, image generation. There are multiple use cases, and it's really exciting, really, the things that we can do with this technology. But we need to find the right balance between innovation and the emerging risks and challenges. We have seen before with the Professor Tamburini, there are risks for the sustainability of the planet. Why building in cloud? Why we think that is the right decision to do it in cloud? As an example, AWS invests in green energy. So in this year, the region in Milan was powered 100% by green energy. So we think that our technology can help the planet. And also emerging risks like the wars. We need to be sure that the technology is in the safe hands and that think to the best for the planet. Why it's complex build a generative AI model? Because in each of us there are biases. And we need to balance those biases. Here there is an example. Imagine we have a service that is named Amazon Bedrock, where you can access some pre-trained model provided by Anthropic and other companies. One is Stable Diffusion for the image generation. What happens if I ask to Stable Diffusion to generate for me an image of a doctor? It could be a male doctor, it could be a female doctor. But what happens if I tell, generate for me the image of a doctor having a beard? So, will be male, will be female. This is something that we need to input in the building of our generative AI. So, what is responsible AI for us? Fairness. It must be fair. It must consider the superpopulation, also the minority of the population. It must be explainable. You must, when you develop a model, you must be able to explain why the model is behaving in this way. There should be a reason. It must be reliable. It must be reliable. Our colleague just told that it shouldn't crash because there could be critical application living in and using those technology. Privacy and security. We have seen use cases for healthcare today. There are regulations, especially in US. There are HIPAA for data privacy, especially in the healthcare. So we need to protect the people. The governance, we must have some processes to be sure that we define practices and enforce them in case of need. And the transparency. So we must be transparent with our stakeholder, with our customers as well, telling why the model is behaving like this. Another example, I can ask to a generative AI model, what is the best model of a car that I could purchase? And he could recommend a specific brand. This could be fine. This could be even fine, but he should explain why he's recommending that brand, that car, so should be transparent in his way to predict for me. The model of development, what we say is people-centered approach. So we should educate the new generation of developers to these topics, and we should build a diverse team. Diversity is a benefit in all the team, having different opinion, different people coming from different parts of the world. Why not? Having an holistic approach, look at the big picture, and engage multiple stakeholders from different parts of the organization: marketing, product management, sales, development. So each of them should provide their contribution to improve the model and the way it operates. Some emerging risks about and challenges about the generative AI. This is very specific. So the hallucination or the fidelity, the toxicity, we will see it in details in the next slide very quickly. Intellectual property and data privacy. Those are other important topics. So the hallucinations. This could be a good example because there is the temperature in the model that you can, when you develop generative AI, you provide them the temperature that is the level of invention, how much the model should invent should help you. And in this case, we asked, tell me some paper about Michael Kearns, and in the answer, there is the risk that the generative AI could invent some titles. To be honest, I'm from Napoli, so I'm from here, I'm at home, and I asked to a model, without making names, the best team of the Napoli across the years. They put players that never played in Napoli. So we must be sure, and this is an hallucination, that the answers provided by generative AI are reliable on this. Toxicity. This is about the model when you provide bad words to the model. So it should be respectful, provide safety, safeguard rails, and also it depends who is using this model. Are we going to develop the model in the same way if it is used by a kid, a baby, or an adult? So it should behave in line with the rules that we define. This is an example in Amazon Titan, that is one of the models developed by Amazon. Sorry, this model is not designed to avoid giving an opinion. So it should be able to refuse the engagement when you ask for some questions that are unfair. Intellectual property. When we do the data collection, we must be sure that we can access that data. If we don't have the rights of that data, they should not be part of our sampling. This is something that should be considered. And another question, what if I ask generative AI to build my picture like in Andy Warhol style? I'm violating some rules because I'm using the same styles or not? This is something that we should consider in our development. Data privacy. We should be sure that we use data that we can access again. And we should be sure that we don't violate any trademark or any let me say, any not only trademark, but also style about the companies. So what if I take the same brand approach like Louis Vuitton, that is really typical, and I tell them, develop me something in such way. I'm violating something in this case. So we must be sure that also for the data we comply with the rules that we want. So this is our commitment. What we do is implementing it. Again, we do it providing AI as a service. This is our philosophy. We provide it on demand. This is very, very important. If you want to train large models, you need a lot of compute capacity. And you can use different services in AWS. As an example, SageMaker is our service for building models in the cloud. But only when you train the model, you use that compute capacity. This is very, very important. So, and you pay only for the capacity when you use it. Then you shut down the resources and you don't pay. That's the benefit of the cloud for those use cases. We want to integrate the responsible AI in our life cycle. So we provide the samples and also artifacts to help the developers to build. We collaborate with a couple of organizations, including the University of Naples, to build the responsible AI, and we want to prioritize the education of the new generation that builds those technologies. Those are two examples. Amazon Titan, we have seen the answer of Titan in one previous slide. Code Whisperer is very, very interesting for the developers. It's free for the developers and for the students. Code Whisperer is a plugin that through generative AI recommends you the code. You can simply write in a comment, write me a function that do the upload of a file using SFTP, it will write the code. Of course, the code will not be perfect. You will adjust it eventually according to your need. It supports the most common languages, so JavaScript, Java, Python, and so on. Another important aspect is often when they talk about hyperscaler, they talk about public cloud. We talk about private cloud. What we do is creating you a private cloud environment that you can access. It's not exposed over internet, so your data is safe. And we provide encryption for all the layers, encryption in transit, encryption at rest. It means that the end-to-end data is secure. This is very important. Of course, in AWS, you will find a couple of services that help you to secure the perimeter of your data, and also systems that help also in case there are external attacks or something like that. So those are the best practices. This is very true. Define the use cases. We have seen it in the past as well. The artificial intelligence typically is very tailored on the use case. You must be very good to define the requirements. Better requirements, better output. This is the story, I would say. Prioritize education and diversity in your workforce. This is very recommended. Assess the risks, not only technical risks, but we are talking about ethics, so ethical risks as well. Test. You need to test deeply, extensively, and try to figure out if there are biases, uncontrolled biases. Iterate across the AI life cycle. We have seen that through inference, the artificial intelligence can learn by itself. So make it an iteration, more iterations about the artificial intelligence life cycle, and introduce governance and policies with the right level of access. Each role should have specific access to the generative AI and be data-driven. So define some KPI that will tell you how you are performing, also from an ethic point of view. So not only at the technical level. I was quick.
Any question from the audience? Okay, I have a couple of important points in my opinion. So, through your presentation, you discussed about the role of education several times.
Yes.
And also, a good way to explicitly motivate this is in this slide where you described the question about the woman and man driving skills. If you think about it, the way the Titan model responds can be seen as a form of censorship, because it's actually performing I had been trained to not respond to this.
Correct.
But actually, I have an idea. I'm not allowed to give it to you, but I have one.
Correct.
Unless you saw it under the light of fairness, ethics, and so on. So only educated people on the use of AI can understand why the model has been designed on that, and why it's technically impossible to make it not able to generate its own idea about it, no?
Correct.
So what is all this preamble was to ask, what is the agenda, to some extent, that AWS is putting on education?
Yeah.
Besides the collaboration, I mean, so in terms of supporting education.
So, again, we come back to the democratization of the AI. AWS aims to be a framework where all the developers can express themselves. We collaborate with the multiple companies that develop, Cohere, Anthropic, there are many more now, I don't have it. So, and we think that each of the model developer has their own ethic. They should be able to define their own rules. And I agree with you when you say that really he has an idea, but it has been put a guardrail there. Don't give you that idea. That's to protect. And it's the governance that we also mentioned during the presentation. So the governance model of Titan said, don't expose an idea that it's unfair. That's it. So it's a set of rules that live together.
As usual, in this case, the problem is who is controlling the controllers, no?
Yes, of course.
Okay, other questions from the audience? Okay, there is one over there. Let me just wait for a microphone if possible. It's over there. Yep.
How are you doing? So we use the Amazon platform. It's a brilliant platform and we get good support. And solution architects like yourself are brilliant supporters. I've seen them in action when a client has a real problem, okay? But suppose you're supporting a generative AI solution that a client is making, and as you look at it, you realize that client is making really big ethical mistakes. What's AWS's position? How is it going to handle that?
So in AWS, we have what we call shared responsibility model, okay? The shared responsibility model means that we give you the tools to build, but we don't tell you what you have to build and what you have to put in your model, even because as cloud provider, we don't have the right to access your data, okay? So to respond to your question is, if the model is public, there could be taken a position by Amazon if it is offending the public or something like that. If the model is private, we don't know it. We simply don't know it, even if you have built it on top of AWS, because we protect our customer data first by ourselves, not accessing their data, okay? So the answer is private models, we don't know. Private models used by private applications, we don't know. If it is public, yes, we could. It happened, but it is not only for generative AI. We did this in the past for some companies offending the public or something like that. There are some rules that must be that the customer must comply. It's in our data agreement.
It's a tricky area for you, and
Yes.
I'm really talking about where you become aware because the customer's asking for help, even if it is a private module. But it's not a final answer, I understand.
Yeah.
Okay, thank you again. Let's thank again the speaker. So this was the last speech for today. I don't know whether you want to. Okay. So I want to thank all the speakers for their time, also all the attendees for having time to join us today. This event was to some extent, final event for the first year of our master, and we are going to start the second year very shortly, as Professor Sansone said. So I hope to repeat this event the next year and to see you again, maybe with a different background, and I'm quite sure the background will be different in terms of policy and of how the generative AI will shape the world.
Yeah, maybe there will be also some news. For example, maybe the act there'll be a definite version of the act. So an important point is that this matter continuously evolves. So maybe when we designed the first edition of this master, some things were unknown to all of us. So there is also the challenge of evolving with the programs, of evolving with the matters, evolving with the contents of different courses. But anyway, as Stefano said, the hope is to see you once again in 2024 to another Vista workshop. Thank you once again.
Thank you again. Bye-bye.
All of you.
Clearly, don't go home because there is the cocktail waiting for us in the other room. So let's have this